Hello students, today we will discuss on the topic that is properties of alcohol. Already in the last class we have discussed regarding the preparation of alcohol. Alcohol general formula is that is ROH. This is the general formula of alcohol. If you see that alcohol contain CO group and OH group. So the chemical properties of alcohol, it depends upon the involvement of CO or OH. In some cases CO bond is involved, in other cases OH bond is involved. But it's mainly when CO bond is involved, in that case alcohol acts as a electrophile. When OH bond is involved, in that case it acts as nucleophile because having lone pair, because it has a lone pair. That's why it can act as a electrophile or it can act as a nucleophile. So what are the properties of alcohol? Let us discuss. First, acidic properties of alcohol. If you take alcohol react with any reactive metals like your sodium, it produce salt, that is RNO plus H2. Here what happens? This is called what? Sodium alkoxide. This is called sodium alkoxide. The salt is sodium alkoxide and hydrogen is produced. So metals like sodium, aluminium, potassium reacts with alcohol forming salt and hydrogen. This reaction indicates alcohol has what? The alcohol showing the acidic character. But generally alcohol will be acidic when it reacts with reactive metals. Then it can displace hydrogen. So alcohol reacts with sodium metal forming salt and hydrogen. This indicates acidic nature. This indicates acidic nature. Acidic nature of alcohol. Then this reaction involvement of OH group forming hydrogen. OH bond breaks forming hydrogen and salt. This alcohol reacts with, already you know that alcohol reacts with PCl5. Already we have read in haloalkane chapter, forming RCl plus HCl, then POCl3. You have to remember, this is very important reaction of alcohol with PCl5. Alcohol react with PCl3 forming RCl plus H3PO3. Here what happens? If you see the plus here 3 alcohol producing 3 PCl3, okay, and 3 H3PO3 is formed. So this is one important reaction of what? Alcohol with PCl5 producing haloalkane and H3PO3. Alcohol reacts with that SOCl2 thionyl chloride forming RCl. This thing already we have discussed in haloalkane chapter, forming SO2 and HCl, and this is very important in the preparation of pure haloalkane because these two are gases. So pure haloalkane can be prepared. Alcohol can be reacts with HCl forming RCl plus water. But this reaction is somewhat slow, not fast. But this reaction will be fast when alcohol reacts with concentrated HCl and anhydrous zinc chloride. This is anhydrous condition of zinc chloride and HCl. Reaction will be fast and forming RCl, and remaining is water, can say. Here what happens, this result, this is called Lucas reagent. It is called generally Lucas reagent. This is called Lucas reagent. When alcohol reacts with concentrated HCl and zinc chloride forming haloalkane, it is obtained as turbidity. Turbidity. Turbidity means white appearance solution will form, that indicate the formation of alcohol. But here the reactivity of alcohol is tertiary greater than secondary greater than primary. In all cases the result will be haloalkane, but tertiary haloalkane gives immediate turbidity, already discussed in the haloalkane chapter, and secondary alcohol gives turbidity after some time, that is the result obtained in late. But here primary alcohol gives turbidity on heating. That's why this is the reactivity of alcohol towards Lucas reagent. Here zinc chloride is anhydrous zinc chloride helps to break this CO bond. This CO bond can be easily broken with the help of ZnCl2. So this is very important reaction of halo, that is alcohol forming haloalkane. So alcohol can be undergo dehydration. If you take CH3, CH2, OH, this is one alcohol having two carbon. It undergo dehydration in presence of sulfuric acid, concentrated sulfuric acid, or concentrated phosphoric acid. Okay, or that is we can use other reagent, that is sulfuric acid, phosphoric acid. It gives what as a dehydrating, or add also ZnCl2. ZnCl2 can be also used. Here it produces only ZnCl2, anhydrous zinc chloride, phosphoric acid, sulfuric acid. It gives alkene. It gives alkene. Ethanol gives ethene. Then water produces. So this reaction is called dehydration of alcohol. This is dehydration. Dehydration of alcohol. Dehydration of alcohol forming alkene. But if you take that tertiary, if you take tertiary alcohol, if you take like this, same condition, same sulfuric acid, condensed sulfuric acid, the result will be alkene, substituted alkene. This is called isobutene. This is called isobutene. This is called formation of, this is also formation of alkene. So alcohol gives alkene when reacts with sulfuric acid or phosphoric acid or anhydrous zinc chloride formation. This is called dehydration of alcohol forming alkene. Then alcohol can be these cases in the formation of bromo or ido. Here you can use also, for in case of bromo ido, PCl5, PCl3, we can use that. Here you can write alcohol reacts with, we cannot use Br3, Pi3 or that Pi5 because they are unstable. In that case, you have to use red phosphorus and bromine, or red phosphorus iodine we can use, and the result will be R, Br or Ri will be obtained. So this reaction also very important. Here what happens, when you use phosphorus and bromine, what happens, this phosphorus and bromine produce PBr3, excess bromine become PBr5 like this, but during the formation of PBr5 or PBr3 it produce PRBr or Ri. So that is very important difference between that. We cannot use PBr5 or PI5 because it is unstable. So in that case we can use red phosphorus and bromine. Alcohol can be easily oxidized. All these reactions, these are all nucleophilic substitution reaction. All are nucleophilic. All the cases use CO bond is involved. Here all the cases CO bond is involved. Formation of haloalkane. All the cases. And this is exception. This dehydration reaction forming alkane. But alcohol can be oxidized. What are the oxidation reaction of alcohol? Oxidation reaction. Oxidation means alcohol can be easily oxidized. What are the oxidation reactions? Alcohol can be oxidized using that strong oxidizing agent. If you take alcohol, that RCS2H alcohol in presence of that KMnO4 and concentrated HCl, or K2Cr2O7 concentrated sulfuric acid. Here acid will be sulfuric acid will be used. Result will be your acid, carboxylic acid. Very important reaction. That means when alcohol undergo oxidation by strong oxidizing agent, the result will be carboxylic acid. But if you use that some weak oxidizing agent like your CrO3 or PCC or PCC. PCC means pyridium chlorochromate. Pyridium chlorochromate PCC in presence, or chromium oxide, result will be aldehyde. Aldehyde. Here acid cannot be produced. Here only aldehyde will be produced because it is not strong oxidizing agent. First step, you know, alcohol when we first oxidizing become aldehyde, and further oxidation become acid. That's why you will get only aldehyde if you use which one? Chromium oxide or PCC. But if you use secondary alcohol, suppose let you use secondary alcohol, then same condition CrO3, result will be ketone. Result will be ketone. Here ketone will be produced. So that but if you use secondary alcohol in KMnO4, if you use secondary alcohol, let it be like this. Secondary alcohol and with your KMnO4 and HCl, the result will be, first step will be ketone. Here as it is a result will be as secondary alcohol, then first step what happens, here two will break, it will produce ketone. First step is ketone, then on further oxidation it becomes produce lower member of acid, lower member of acids. So it depends upon the oxidation. If you use tertiary alcohol, let it be like this. Then first oxidation using KMnO4, it will produce ketone, and if you see, generally result first step will be alkene. If you see, the first step will be alkene. First step actually it will be alkene. First step will be alkene. Let it be like this. Alkene will form first oxidation, then it further oxidizes to like this ketone and formic acid. So this is the oxidation product of the tertiary alcohol. So this much remember, when alcohol gets oxidized by strong oxidizing agent like this acidified potassium dichromate, potassium permanganate. Result will be acid. Mainly that is ketone and acid if it is tertiary. Then alcohol can be oxidized by weak oxidizing agent, that is copper powder. If you use primary alcohol, you will oxidize by copper metal on heating. Result is aldehyde. Then hydrogen. This reaction is called loss of hydrogen resulting oxidation. It is also an oxidation reaction. Secondary alcohol. If you use secondary alcohol, same copper powder on heating, result will be, what happens? Result will be ketone and hydrogen. Result will be ketone. But if you use, this is primary alcohol, this is secondary alcohol. If you use tertiary alcohol, same copper powder and heating, but here you will not get aldehyde ketone. Here under this, always remember, tertiary alcohol will be oxidized to alkene. The first product is alkene. R. If R is a methyl group, we have written like this: RRC11CH2. Thus, suppose it is methyl. Let it be methyl. Let it be methyl. To understand the reaction, you can write this one. Let it be methyl. If it is methyl, result will be alkene plus water. And this is called dehydration. In all cases, dehydrogenation, loss of hydrogen. Loss of hydrogen means dehydrogenation. Loss of hydrogen is called also oxidation. So that alcohol, when it oxidizes, produce aldehyde. Secondary alcohol gives ketone. Tertiary alcohol cannot be oxidized easily, but it undergo dehydration, forming alkene. So this is about the oxidation of alcohol. So what are the next other reaction? Then if same alcohol reacts with concentrated sulfuric acid on heating about 413 K in presence of excess alcohol. If excess alcohol will be taken and reacts with consulfuric at temperature of 413 K, result is ether. Ether is produced. This is ether. Ether means ethoxyethane or diethyl ether. So it only depends upon the concentration of alcohol. If alcohol will be taken more amount, highly concentrated alcohols, and that low temperature sulfuric acid produce ether. But same alcohol, that when the amount of alcohol will be less and same concentration sulfuric acid, but at a high temperature 441 K, already discussed, alkene is produced. Already same sulfuric acid but 441 K, result is alkene. So this is the difference, that alcohol sulfuric acid produce ether and alcohol sulfuric acid produce alkene. Both reaction is called dehydrational reaction. So what are the mechanism? let us discuss the mechanism of dehydration of alcohol. What are the mechanism of dehydration of alcohol? In the first step, what happens? Step 1, this alcohol will react with acid as a catalyst. This reaction is the first reaction. First reaction results formation of protonation, that is called protonation. Protonation. This is called protonation. Addition of proton. Then second step, what happen? This CH2, CH3, CH2, OH2 plus. This step is slow step. Results formation of carbocation plus water. Carbocation. Then in third step, what happens? Deprotonation occurs. This CH2H and CH2 plus will lose hydrogen, that is minus H plus, produce alkene. So three step results the formation of alkene. This is called what? Dehydration of, mechanism of what? Dehydration of alcohol. It is generally asking in your exam, dehydration of alcohol forming alkene. But what is the mechanism of formation of ether? Let us discuss. That is also very important. Second mechanism is, if use alcohol, let it be CH3, CH2, OH, in presence of this reaction is your first reaction forming CH3, CH2, OH2 plus. This is called proton. This reaction is called deprotonation. Deprotonation. This is deprotonation. First step is protonation. But deprotonation is your first step, and deprotonation also slow step, and loss of water also slow step. Then this protonation, then what happens? Another alcohol having lone pair acts as a nucleophile, reacts with carbocation. Then what happens? Here it attack to this carbon, then loss of water molecule. Then what happens? Here CH3, CH2O, CH3O, then H already is there, here become plus, then CH2, CH3. Here attacking of oxygen towards carbon. So it is in that, it's called nucleophilic substitution. Nucleophilic substitution reaction. Nucleophilic NS reaction, nucleophilic substitution reaction, attacking of nucleophile to the carbon. And from this, the leaving group will be leaving from the group will be leaving from the carbon atom. This is called your nucleophilic substitution. Then formation of this, then what happens? Then it will undergo loss of H plus, forming ether. So this mechanism is called nucleophilic substitution, and this mechanism is called elimination. Loss of, you see, alcohol to alkene, elimination. First one is elimination, second one is substitution. But this is nucleophilic substitution, this is the called what? Loss of water molecule, forming alkene. So this is the mechanism of dehydration alcohol, forming ether and alkene. Then very important thing is that alcohol reacts with acid, that is called esterification. The reaction is called esterification. Very important reaction. Esterification. in esterification what happens here, acid, lead acid RCOH reacts with alcohol R-OH in presence of sulfuric acid and forming ester RCOO R- plus water. Here loss of water takes place, and this reaction is called esterification because formation of ester. That's why it's called esterification. If you see the mechanism, that is also very important for this mechanism. This reaction can be written like this. First you have to take acid. This is acid. Then it accepts H plus ion by this keto group. Electron density of oxygen is more. Then R, C, double bond OH plus, then OH. First step is like this. Then what happens? In the second step, this react with your R-OH having lone pair. Then this lone pair attack to this and forming breaking of double bond. A result is R, C, OH, then OH. Then what happens? That OH plus R dash. Then what happens? Here, this hydrogen immo as proton, then added to OH because it will be lost from the oxygen and added to oxygen. Then what happens? Here all the reaction is reversible nature. Then what happens? Result formation R, C, OH, then OH2 plus because it will remove from oxygen added to OH. Then OR gas remain. Then here what happens? Here it will lose hydrogen and here H will remove and form double bond, then water will remove. You have to write this. Loss of proton forming double bond and loss of water. Simultaneously it takes place. Then formation loss of water occurs and loss of H plus also occur. Both loss of H plus, loss of water and forming your ester. R, C, double bond O, then O, R dash. This is ester. Ester is formed. So these are you see first attacking of that is called protonation to keto group, then attacking of nucleophilic addition reaction. This is called you can say this is nucleophilic addition. Then formation of single bond, then loss of proton, then proton again loss of proton, again proton, that is protonation, deprotonation and protonation occurs, then loss of water molecule forming ester. So you have to practice this. This is called mechanism of esterification. So alcohol reacts with not only reacts with acid, all acid derivative reacts with alcohol forming ester. All acid derivative. If you take alcohol, that plus your any acid derivative RCOCl or RCO, that is it is acid halide, this is acid anhydride. If you take all the case in presence of acid forming ester, RCO R dash, the result will be always ester. Remember, alcohol reacts with acid or acid derivative in presence of your acid forming sulfuric acid forming ester. Then what are the physical properties of alcohol? Physical property of alcohol, that if you already you know physical property, physical nature. Physical nature is very important. You see alcohol water soluble, it is water soluble because it can form intermolecular hydrogen bonding. And second thing is its alcohol boiling point is greater than your aldehyde ketone, then ketone aldehyde, then ether. It's very important, you have to remember the boiling point difference. First is alcohol, then ketone, then aldehyde, then ether. This is the boiling point because it produces intermolecular hydrogen bonding, strong hydrogen bonding. That's why boiling point is more. And alcohol is colorless, lower member colorless, and burning. That burning test means your tongue will burn, irritation of tongue, that is burning test, and that colorless burning test, and we can say neutral to litmus also, neutral to litmus, colorless burning test, and pleasure, that characteristic odor, alcoholic smell. Then we are telling spirit, that alcoholic smell, water soluble. So these are some. Then highly combustible. Alcohol is also highly combustible. When alcohol is, suppose you take ethanol, when burned in presence of oxygen, forming carbon dioxide and water. That's why it produces energy plus heat. That's why this alcohol is called fuel alcohol, because it produces energy. That's why it can be mixed with that petrol to improve the quality of the petrol. So these are some important reaction of chemical properties of alcohol. In the next class we will discuss the preparation and properties of phenol. Okay, thank you all.